Yes, good morning. Good morning once again. This is Kidevo Online Academy, the biggest channel in Tanzania and all over the Africa. And today you are with your teacher, Mr. Kidevo. Today we have the assignment here of summarizing the topic of relation and function. As we know that in Form 3, this is among of the topics of Form 3. So we are going to summarize the topic of relation and the function. So our topic today is relation. Yes, this is relations and the functions. As if you're not very carefully, you'll see that these two terms are similar. These two words are similar, but they are quite different. We have relations and we have function. So we have to move step by step. We have to see what is relations, how can we draw the graphs of relation, how can we check the elements which comprises two sets, how can the elements of the first set relate with the elements of the second set, and how can we represent different relations. But also we shall discuss about the function to see the definition of function, what is function, what is one-to-one function, the different types of function, how can we find the domain and range of functions, and how can we draw the graphs of function. So by starting, let us see the relation, what is the definition of relation, and then we shall move to discuss about the functions, what is function, and then after making the discussions of these two terms, we shall see now the difference between these two terms. We shall see the difference between relation and the function. So by starting, let us see and discuss about the relations. Yes, now in mathematics, when we speak about relation, this is a set of all ordered pairs. Is a set of ordered pairs which consists different elements of the first set and the second set. And we have to see how do these elements of these two sets relate. So we have a sum of elements of the first set, and then we have a sum of elements of the second set, and then we have to see how do these two sets relate. How do these elements of the first set relate with those elements of the second set? So if we speak about relation, if we mean about the relation, so by definition, simply say this is a set of ordered pairs which consists of two sets whereby each element of the first set belongs to one or more than one element of the second set. Yes, so this is the meaning of relation. By definition, this is a set of ordered pairs. It means if we speak about a set, here we are talking about the two groups. It means we must have the first group and the second group. And then in each group, there are elements. So in relation, we have to see how do these elements of these two groups relate. How do elements of the first group relate with the elements of the second group? So this is a set of ordered pairs which consists of two sets. two sets means it consists of two groups, whereby each element of the first set belongs to one or more elements of the second set. It means that one element of the first set can belongs with or can relate with one element of the second set, or one element of the first set can belongs or can relate with two elements of the second set or three elements of the second set. So simply we say one element of the first set can relate with more than one element of the second set, and vice versa is true. When I speak about the vice versa is true, it means one element of the second set can also relate with more than one element of the second set. So an element of the first set can relate with one or more elements of the second set, and also an element of the second set can relate with one or more elements of the first set. So this is what is a relation. This is what is a relation. Is a set of ordered pairs which consists of two sets, whereby each element of the first set belongs to one or more than one element of the second set. So this is the real definition of the relation. For example, consider the pictorial diagram below. Consider, for example, consider the pictorial diagram below. We have this pictorial picture. It means this is the first set, and then we have the second set. We have the second set. Maybe this is set X and this is set Y. And the elements which make the first set are maybe 1, 2, 3. And the elements which make the second set, maybe these are A, B, and C. So this is the first set, and this is the second set. Inside each set, there are elements. The elements of the first set, we have 1, 2, and 3. And the elements of the second set, we have A, B, and C. So maybe number 1, so here there is a relation, ara. So ara means relation. It means that these two sets, they relate. And maybe an element number 1 in the first set relate with A, or number 1 can relate with B, or number 1 can relate with C. Maybe number 1 relate with the second element of the second set, maybe B. And number 2 relate with C in the second set. Number 3 relate with A in the second set. So this pictorial diagram, this pictorial picture, it represents two sets, set X, the first set, and set Y, the second set. And these are elements of the first set, which are 1, 2, and 3. And in second set Y, we have elements A, B, and C, whereby number 1 relate with B, number 2 relate with C, and number 3 relate with A. So this is an example of a pictorial diagram which show the two sets, whereby the two sets relate. It means that this relation have been represented in pictorial diagram. The same relation can be represented in a set of orderly pairs, because sometimes the question may ask you to express the relation in either pictorial picture like this, or you have to represent a relation in terms of ordered pairs, or you have to represent a relation in terms of an equation, or you have to represent a relation in a graph. So we have varieties, we have different ways whereby we can use them to represent a relation, the same relation. So here, our relation have been represented in terms of pictorial picture. We can also represent the same relation in terms of orderly pair. How? It means this is a Roman 1 in pictorial picture. Now Roman 2 in ordered pair. The same relation can be represented in ordered pair. How? It means this will be R. Now R stands for relation is equal to, you put this curly brackets. Now it is a relation of which sets? A relation of two sets. What are these two sets? We have set X and Y. So here inside you say a relation of X, Y, such that. So X, Y, it means these are two sets such that number 1 relate with B. So you can write here number 1, B. Then number 2 relate with C. So number 2 relate with C, comma. Then number 3 relate with A. Number 3 relate with A, over. Now this is the relation, the same relation which is represented in orderly pairs. Yes. So this is what is a relation, and this is an example of the elements of two different sets relate. But sometimes another example is maybe example 2. We have this pictorial diagram again. This is set X. This is set Y, whereby X relate with Y. And here we have maybe 1, 2, 3, 4, 5, 6. Here we have A, B, C, D, E. So number 1 can relate with C. Number 1 again can relate with A. Yes, this is possible in relation. As what we said in the definition of relation, we said one element of the first set can relate with more than one element of the second set. So an element of the first set, which is 1, can relate with A, but also number 1 can relate with C. That is possible in relation. But also we have an element which is 2 can relate with maybe only one element of the second set, which is B. That is possible. In relation, that is possible. So we have number 1 goes with A, number 1 goes with C, number 2 goes with B. Yes, that is possible in relation. Number 3 can go with D. Number 3 again can go with B. Yes, in relation, this is possible. One element of the first set can relate with one or more than one element of the second set. But also, if you see B, also B is an element of the second set, can relate with more than one element of the first set. So B is an element of the second set, which can relate with more than one element of the first set. As you can see here, element B goes with number 2, but also element B goes with number 3. In relation, this is possible, no problem. As from the definition we said, one element of the first set can go with one or more element of the second set, and vice versa is true. Vice versa is true means a single element of the second set can go with more than one element of the first set. So this is the relation. Then we have number 4. Number 4 can go with E. Number 4 also can go with A. In relation, this is possible. One element of the first set can go with one or more than one element of the second set. In relation, this is possible. We have number 5. Number 5 can relate with C. This is possible. But also number 5 can go with E. This is possible. In relation, no problem. So 5 can go with 2 elements of the second set. We have number 6. Number 6 can go with only one element of the second set, maybe number D. Yes, so this is the real definition of a relation. One element of the first set can map or can relate with one or more than one element of the second set, and one element of the second set can map or can relate with one or more element of the first set. Yeah, so this is a relation. This is the real meaning of relation. Now, this relation have been displayed or represented in pictorial diagram. This is pictorial diagram. But the same relation can be represented in terms of ordered pairs. Now, in ordered pairs, ordered pairs, how can we represent this relation in terms of ordered pairs? Yes, we start with R. Now R represents relation. Relation of which sets? We have relation of two sets, X and Y. So this is X, Y, such that we have number 1 goes with A, brackets, but also number 1 goes with B. Yes, that is over. Then we have number 2. Number 2 goes with only one element here, which is B. So number 2 goes with B. Yes. Number 3. Number 3 goes with B, bracket, but also number 3 goes with D. Yes. We have number 4. Element of the first set, number 4, goes with A, but also number 4 goes with E. Yes. Number 5 goes with C, but also number 5 goes with E. Number 5 goes with E. We have number 6. Number 6 goes with only one element, which is D. Yes. Yeah, so this is relation in ordered pair, and this is relation, the same relation in pictorial picture. So relation can be displayed or can be represented in different ways. As what I said, you can represent a relation in pictorial picture. You can represent relation in ordered pairs. So if there is a question, ask you to display or to write or to express a relation in ordered pairs, we have to do like this. In pictorial diagram or pictorial picture, we have to do like this. But also we have other ways whereby you can use them to display or to represent a relation, like an equation. We can represent a relation in terms of equation, but also you can represent a relation in terms of graph. Yes, graph is possible, but also you can represent a relation in terms of table. Yeah, so we have different ways whereby we can use them to represent a relation. But also in relation, there is something called the domain and range. As what I said previously when I start my lesson, I said, yeah, today we are going to summarize the topic of relation and function. What is relation? What is function? And how do these terms relate? And how do these terms differ? Yes. So, in relation, we have something called the domain and range. Now, in reality, or simply when we speak about a domain, here we are speaking about all elements of the first set. All elements of the first set. This make a set of domain. But also we have range. So we have domain. Yes, domain. We said these are all elements of the first set. So according to our example here, it means the domain. What are the domains? Domains are, we have 1, 2, 3, 4, 5, and 6. These are elements which make the first set. So all elements which make the first set, these elements are called the domains. And those elements of the second set, here, these are elements of the second set. We have A, B, C, D, E. So all elements of the second set, they make another set of a range. So we have domain and range. Domains are all elements of the first set, and range, these are all elements of the second set. So according to our example here, if we have been asked to display the domains, to say the domains now, domains is equal to curly bracket. But if you see here, the domains are all elements of the first set. Now, what is the first set? The first set is X. So, domain, these are values of X, such that according to our example, our elements are 1, 2, 3, 4, 5, and 6. So these are elements which make the first set. These are elements which make the set of domain. So we have 1, 2, 3, 4, 5, and 6. And 6. Yes. So these are domain. These are domain. And range. Range said these are all elements of the second set. Now, according to our example, range is equal to, now the second set is a set of Y. So range is equal to value of Y, such that now elements which make the first set, which is Y, are A, B, C, D, E. So these are range. So range, you have A, B, C, D, and E. So all of these are elements of the second set which make a set of range. So this is relation. We see how do elements of the first set relate with those elements of the second set. Yes, good. Now, after discussing a little bit about relation, now let's move to function. But before moving to function, let us give you the other ways which are used to represent relation. Methods used to represent relation. We have the first, which is pictorial diagram. Or pictorial pictures. This is the first method. But also, we can represent relation in ordered pairs, like what we did. But also, we can represent relation in terms of graph, or we can represent relation in terms of equation, but also we can represent the same relation in terms of table. Yes. Yeah, so these are methods which are normally used to present the same relation, Now, after summarizing the relation, we have discussed about what is relation and the elements which make the first set and the elements which make the second set. How do those elements relate? And then we discussed about how can we represent relation in pictorial picture and in the ordered pair. But also here, these are methods or ways which can be used to represent the same relation. Now, after relation, let us move to see the function. What is function? How can we represent function? How do function differ with relation? The similarities and the differences of relation and function.